Hey, hello everyone. So for today training, we're going to start. So for today, that we're going to cover. I think everybody should see my screen. So the screen over here, you'll be telling you that today the topic that we're going to go through will be on the security. So on the H12, 711, HCNA security CBSN exam outline. All right. But first of all, let me introduce myself again. So I'm Nick Yap. So you can call me Nick. So and the entire video for these 3 hours will be recorded. So if let's say that you have any question, you can just raise your hand and we're going to unmute your section. Otherwise, they have until the end, we have 30-minute Q&A section. You also can ask questions during that time. Also using the raise hand button. Then we're going to unmute you. Then we're going to performing the Q&A section. All right. So for today, these 3 hours they will cover on the security, CBSN, for the constructing the basic security network. So that will be the part 1 of the exam under the HCNA security. So that is the coding H12711 ENU. So it will be the same as the RNS I mentioned yesterday. So the duration also be 90 minutes, and the passing score is 600 over 1000. All right, so it means that it's the same as well. In total, you have 60 question. So under the CBSN, the constructing the basic security network, they will going to cover the network security basic, a firewall basis, such as the packet filter, network address translation, VPN technology such as the IPsec, SSL, as well as their implementation in the Huawei product. So it means that first of all, we are going to go through the technology. Then after that, we are going to show you that how this technology apply into the Huawei product. And as well as the firewall user management, UTM, technology and implementation, as well as the terminal security with the security policy configuration. So it means that they also can be prevent the threaten of all the different type of attack, virus, Trojan, as well as the terminal security on the user end. User point of view, we also can provide on the security. So that will be the content under the CBSN. Under the knowledge point, so they have few knowledge point over here. First of all, be the first one as a firewall. So firewall over here, they cover as a basic principle of the network security. So how are we going to provide the security throughout our network, and what type of method, the classification, the mood of the working mood, how we're going to specifying the security zone, basic features, as well as the basic configuration. The packet filter technology and the configuration on the interface and between a zone. So only a firewall they can specify based on the security zone. So they can define multiple zones for us to perform the packet filtering through the ACL application and the configuration. As well as for our firewall, the support on the netting, a net technology, a network address translation. So it means that how we are going to translate the private address going through the public address. And for the netting, they have different type of the netting. Net based on the source IP, net based on the target IP, net between outside or inside zone, bidirectional netting, net server, and the target netting. So they have different method of the netting that need to be going to be covered, as well as a firewall dual system hot backup technology and configuration. So how we're going to, when you have two firewall, how they're providing the redundancy. Firewall user management, authentication through the AAA concept, and the VLAN technology, WLAN, WAN interface features. Okay, that is on the firewall basic. Okay, you also can apply as a layer 2. For the firewall, can be a router, can be a switches. So throughout the VPN, they will based on the VPN basic principle, the classification, and also the encryption technology. So that will be involved of L2TP, GRE tunnel, IPsec, as well as the SSL. And the SSL is the most common nowadays for the host to the gateway. The IPsec is also very common when you're providing a site-to-site VPN. As well as they're going to have the UTM technology, Unified Threat Management, how you're going to prevent all those attacks, like the DDoS, like the IPS, IDS, all this information be under the UTM concept, as well as the terminal security, concept deployment and policy configuration of the terminal security. So it means that they're going to provide on the based on the end user, what type of end user that you can going to be protected. So that will be the just a rough of the content that you're going to come out from your exam. So you see that you found that the main topic, the knowledge point, is within the firewall itself. There are the 7 points, as well as the VPN. So these two, you need to go more in depth into it before you go for the ICT competition. All right, this will be the outline under the entire CBSN. So for this security training, they're going to cover 3 of the topic. So before that, let me show you on the timetables that what we're going to define, what we're going to cover actually for today. Today, we're going to cover 3 of the topic. Okay, so the first one, they were going to cover based on the basic firewall technology. Followed by the firewall security and also firewall dual system hot backup. These are the 3 topics they're going to be covered within these 3 hours. All right. So for the first one that we are going across, will be the basic firewall technology. So why we need firewalls? This start from chapter 2. So the outline just now is on the chapter 1. All right. All right, so let's get started. For this one, it's based on the basic firewall technology. So what are the features and why we need a firewall and what type of mode that we have to support on the security of our network. So under the objective, they're going to cover from here, you be the definition and the classification of the firewall, the main functions of the firewall and the technology, firewall management method, and the basic firewall configuration. So they're going to show you a basic configuration on the firewall itself. So first of all, we're going through on the firewall overview. So at the first place, why we need a firewall? Let's have a look from this point. So based on this environment here, we have an intranet. This is your local LAN. All right. So for the attacker, without a firewall, they can be easily from public network go into your private network easily. Let's say you do not have any prevention. That's why we are going to provide a firewall in between the intranet to the internet. Okay, so most of the threaten, it will always come from the public network. So definitely we cannot say guarantee that all the threaten is come from the internet. Definitely some of the threaten can be internally into your local intranet as well. So that is another method to prevent that. But for this, for now, that we're going to mention on this firewall is between the internet and the intranet. So we are going to perform as a firewalls. So based on the firewall itself, they can be filtered for the logical areas. So we can easily, throughout the firewall, we can define a logical zone. So we define as a zone. So I can say that that is on the trusted. This is on the trusted zone. So under the trusted zone, to make sure that everything inside the trusted zone, whenever they go out, I can be allowed. So it can logically divide multiple interface under a single zone. And for the internet, I will say that this is a untrust zone. So this order zone, it can be specified logically. And the high the intranet structures. So in this case, when I'm going to have a firewall in the meters, all the traffic by default from the internet, they can't go into my intranet. So I can hidden everything. And also by using a never address translation. Through the never address translation, outsider, you never know that what is my private address. So under my intranet, it's all go through the private IP. But my internet is all my public IP. So it can be easily hidden what is your intranet structures, as well as they have a self-security guarantee and active attack defense. So all these two is all done by the firewall itself. Under firewall itself, I can be easily just enable the attack defense. So that can be filtered, all the critical attack come into your firewall, that can be filtered automatically. So as far as, is it possible to protect data flow that do not go through the firewalls? So what I mentioned just now, all the 4 points here is the traffic must pass through a firewalls. But what happened in, let's say, locally into the LAN? How they're going to protect themselves? So that's why all our PC or our server, they will have their software firewall included as well. So it's not just this one requires a hardware firewall. So every single PC that we have or server, they will having their software firewalls has been installed and to protect themselves. So it's not everything need to be going through the firewall, through the hardware firewalls. Okay, that will be just a roughly overview of why a firewall is needed, is to prevent all the threaten come from the public network into your private network. So under the firewall classification, as I mentioned just now, by the form, there can be a hardware base or based on the software base. So based on how they are going to handling the filtering, they use based on the software base or based on the hardware base itself. And by protected target, a standalone firewall or the network firewall. So standalone firewall is just like what we have installed into our PC. And the network firewall is what I showed you just now. All the traffic, they're going to pass by the network firewall before they go into your private network. And by the access control method, they have 3 different methods. Okay, they can be based on the packet filtering firewall, a proxy firewall, and also a stateful inspection firewalls. But most of the time, which one that we are using? We are using mainly onto the stateful firewalls. All right, so it means that this one stateful firewall, they provide a more secure compared to the packet filtering and as well as a proxy firewalls. We are going to go through one by one with all the 3 different of the classification. The first classification that I go through is a packet filtering firewalls. Based on the packet filtering firewalls, what I'm going to perform here is, so when I want to send a traffic from my PC to a server, from a public to a private or private to private. So they're going to the TCP layer, IP layer, data link layers. They pass through the firewalls. So what the firewall perform? They perform the headers. Detect the headers only. So what is your IP headers? What is your TCP headers? That is what the maximum they can go up to, and they will not check about your application, because this one is just mentioned is a packet filtering. So the most that can be filtered is up to the layer 4, up to the transport. Okay, transport layers. So that is what they can be up to, and that what they can be filtered up to, like this. So for number 1, that the disadvantage of the packet filtering firewall, they cannot correlate data packet. Because I will not know what is your layer 5, what is your application layers, and that does not apply to the multi-channel protocols. What you mean by the multi-channel protocols? So it's just like some sort of the traffic, the protocol like the FTP. By using the FTP, they're going to have 2 different type of the port numbers. There are 2 different ports. They have port 20 and they have port 21. So port 21 is for them to send the control. The other one is sent for the data. So by using the packet filtering itself, it's not possible for me to support the multi-channel protocol like FTP. So what I can be filtered in the packet filtering firewall, some sort of the telnet, HTTP, all those a single channel. When single channel, yes, you can go for the packet filtering firewalls. And number 3, packet filtering firewall that does not check the application layer data. So that what I mentioned just now, they can go up to the layer 4. This is a layer 4. This is a max. That can be that can be checked up to. Okay, that is on the packet filtering. It's just purely based on your IP headers as well as your transport layer headers. And the next one is on the proxy firewalls. So there's a second classification. As in what we said is a proxy. So it means that a proxy we call it as a agent. It's one agent to help you to perform. So it means that you will not go direct to the server. I will ask a middleman for you to perform the entire authentication or request, something like this. When the extranet terminal, they want to go to the intranet server, they will not allow you to go direct. Everything, you send a request to the firewalls. First, send a connection request to the firewalls. So firewall is based on this information, you security check on the request and block if it's failed to be checked. So they're going to check what's the request information that received from the external terminals. Okay, so after it check, they're going to establish a connection with the client. If the request passed the security check, they need to go for the firewalls. So it means that depend on the rules that do you allow this terminal to access into my intranet. Let's say it's a pass, they will establish a connection with the server if it passed the check. So you can see that for you to form the section is from the firewall to the internal server. I form another section between the external terminal to the proxy firewalls. So every time when you want to, section has been formed, every time you want to send a packet is sent to who? You send to the proxy. Proxy send to the intranet server. So this is always how it happens. So when you enable as a proxy firewalls. When reply, I not reply directly to the terminals. I reply to the proxy. Proxy send to the extranet terminals. So it's just like a middleman. So in this case, when you have a middleman in the middle, all the information that you send, you're going to take more time. Because every time you cannot go direct to the server. What you need to go to the proxy before you go across. That's why they will have a disadvantage from here. They will have a slow processing. Okay, they have a slow processing, and also they have a difficult to be upgraded. All right, because everything will be just part. Maybe make sure that the agent have to doing well. Okay, the agent cannot be go down. When the agent go down, it means that totally they can't communicate from the external going to the intranet. That is what we call as a proxy firewalls. All right, and the last one is called as a stateful. The stateful inspection firewalls. So on the host 10.0.0.1 want to form a section going to the server 20.0.0.1, let's say. So that is my IP headers. This is my IP headers. Okay, this is my transport headers. So I have two different headers here. So the header will tell me that right now I'm going to do the TCP sync. So need to form the TCP section, go across, go into the server. By the time that when I go through the firewall, they perform the security policy check, record the section information. Okay, so right now this firewall is not a middleman. It's not an agent. What this firewall perform, they keep a record that what information that you send out from the network for you to form the TCP connection. So I'm going to record the section information. Then I send over to the server. So when the server receives that, they'll send a reply. They will send a TCP acknowledgement, TCP sync. Because as we know that throughout the TCP, they need to go for three-way. Sync, ACK, sync, and ACK. So that will be the three-way handshake. So this now is the first message to tell the server, hey, I want to form a section with you. So after I send, so the firewall itself, they're going to keep the record to say that from 10.0.0.1 to 20.0.0.1, I have a TCP sync that's been sent out. So when the server send back the reply, acknowledgement, send back to the servers, so security policy check, record section information. So whatever that I receive, I need to compare back this is my section. So make sure that they come from the correct source and destination. When this is confirmed, only this message can be sent back to the host. Okay. After confirm, this can be sent back to the host. All right. So you found that. You see that the difference from here, sir? Let me just review back. So that is what I sent. I sent the firewall, keep the section, and send to the server, record the sections, and send to the servers. When return 20.10.1.1 back to the firewall send back to the host. So what they need to check, the source and destination compared to my section that I have under my firewalls. Then I'm going to have state error that will drop. So it depends because as I mentioned just now, the state will be start from what? Start from TCP sync. Then I have an ACK and sync, then followed by ACK. So when you return traffic, send back as a TCP sync, so it means that it's not belong to the same section already. So in this case, they are not follow the state. So the normal state, this should be acknowledgement. So that when it's not matched, they're going to be dropped. They should send back the TCP acknowledgement for them to able to establish the entire sections. Okay, so they need to keep track of your state. The state is very important when you form the TCP connection. Yeah, this is on the stateful inspection. So before you go out, I capture. When I come in, I compare what I captured just now and also compare the state. Did I receive the correct state? All right. So for this stateful inspection, firewall is rapid processing of follow up the packet, and they have high security. So every single packet that is going out, I need to compare. Do I have the same state or section that has been created earlier on? So that is on the stateful inspection firewall. So for the next one is on the layer 2 Ethernet interface. So for the firewall networking, they can be based on transparent or can based on routing. So under the network features, transparent to the network topology, no need to change of the networking. So what it means by this is before the firewall installation. Under the internet, you have the 10.1. Under the trust internet, you have a 10.2. When you apply your firewall in the meters after the install of firewall, they are still within the same segment. So it means that right now this will act as a layer 2 firewall. So it's just a transparent. Whichever traffic go across, just a transparent, but they still perform all the checking. So what they did not need to do from here is they just do not need to change your networking under the layer 2. But as in layer 3 Ethernet interface, then you need to have a more step, okay, under the layer 3 Ethernet interface. So for the networking features, they support more security features because this one, you go up to the layer 3. Layer 3, definitely they have more security features that can be supported and has some influence of the network topology. So for this, you might need to modify your addresses. Your addresses scheme have to be modifying. So that is a before firewall installation. So I will have a 10.1, 10.2, 10.129, 10.130. Okay, so I have two segments here. But when you apply a layer 3 switches, layer 3 firewalls, that is running as a L3 firewalls. Under L3 firewalls, I need to define a different address segment from here. So from earlier on, I have one segment, two segment. But after you deploy the firewall into it, you should have one segment, two segment, three segment, and four segment in total. 10.1, 10.5, 10.129, and 10.133. Let's say you want to having the layer 3 firewall. It's a layer 3 capable firewalls. Okay. Most of the company, most of the enterprise network are using a layer 3 instead of using the layer 2. Because layer 3, you can apply more of the features on the security features. So that would be more recommended. So that would be all the firewall method, the mood of the firewall we have to decide before we define the security zone, configure all the policy. So we have to specify that what type of the mood you are using. Are you using a packet filtering? Do you using as a proxy, or are you going to use it as a stateful? And you want to use under layer 2, or you want to use under layer 3? So regardless of which mood that you are using, you still need to know about what is security zone. Under security zone is to telling you that who you are. That only can be created under the firewalls. So a security zone is a local logical security areas based on which most secure policy are implemented. So it means that in the later part, when we talk about the security policy, have to be tied together with your security zone. So the zone is just like a VLAN I mentioned yesterday, is the logical grouping of the interface, which zone they belong to, for you to simplify performing the filtering between your trusted network going out to the untrusted network or to the DMZ network. All right, a security zone is a set of network connected by one or more interface. So you can say that, oh, the entirely on top over here, this is all my server. Let's say my server farm. My server farm, I call it as a DMZ. And this is my local area network. I define as a trusted. And untrust is all connecting to the ISP. But definitely you can define your own self-defined zone. Okay, but definitely they have all the default zone has been predefined for you. Like they already have the untrust, DMZ, trust, local. Okay, that the zone has been defined already at the first place. So every single security zone they define here, they already define a priorities. Okay, they have a priorities of every single zone. The priority of the zone will be from 1 to 100. Okay, the highest the priority are, they will be more secure. It'll be more safe. Like at the untrust, they only have priority of 5. DMZ 50. Trust 85. Local 100. So, but you ask, where is the local? Where is the local zone? Let's say based on this environment that we have, based on this environment, so we have a DMZ, we have untrust, we have a trust. This one can be a trust or can be the user defined as a user terminus. But where is the local? Local is a firewall itself. So it means that when the traffic originated from the firewall is under local zone. Okay, so the local zone has been defined as a firewall itself. It's considered as a local zone. Okay, but definitely you also can assign. You can assign the interface into the local zone. It's up to how you configure into your firewalls. So they support the user security zone as well. So it depends how many zones that you define. So for the security zone in total, so under the Huawei firewall, we call this as a USG, Unified Security Gateway. Okay, they can be up to in total 32 security zone. That's the maximum zone that we can be apply. All right, and the maximum is 100. So the priority has been assigned. You can't modify. So the untrust, DMZ, trust, local, 550, 85, 100. 4 of this priority cannot be modified. What you can modify is only under the user zone. So you depend on how critical they are. Maybe you can set this one to be 80. This user zone be lesser, 60. So this all is defined by the administrators. And this value can be easily modified. Okay, this is under the security zone. So it can be a DMZ, untrust, trust, and the user defined. Or it can have multiple trusted zone. Okay, one single zone can be tied with the multiple physical interface, like what I said from here. So the relationship between the firewall security zone and the interface. So I have a G002, G000, G001, and G003. So as in G002, I assign into the DMZ zone. G003 as an untrust zone. So you found that the G000 and G001 both are under trust zone. Okay, it's possible. It means that a single zone can apply to multiple physical interface, but one interface can only belong to a single zone. Okay, one interface can be only applied to a single zone. You cannot say that this interface belongs to trust as well as untrust. We can't define that. They will give you the error. Let's say you assign like this. So whether can the firewall have two security zones with the same security level? No. Okay? It's not. They will not allow you to set the same security level. You have to using the different priority levels. For whether does the firewall allow one physical interface to belong to two different security zones? No, they're not allowed as well. As I mentioned, they can be only belong to a single security zone only. Whether can different interface of the firewall belong to the same security zone? And this one, yes. So two different interface is under a same trusted zone. That is allowed. Okay. So one more time. Two security zone with the same security level is not allowed. They will always to say that this priority level has been assigned. And you cannot have one physical interface belong to two different security zone. It's not allowed. And the last one, different interface of the firewall can belong to the same security zone. And this one is allowed. All right. Next one. How are you going to define inbound and outbound directions? So what is the inbound direction? What is outbound direction? So it means that in the later part, when you perform the inter-zone filtering, you need to specify this filtering is going through inbound or outbound. So that has to be specifying first. Okay, I will just say that like this. I will say trust, untrust, inbound. So based on this keyword, trust, untrust, inbound. So how are you going to interpret this? Did I perform filtering from trust to untrust or untrust to trust? The keyword over here is the inbound or the outbound. So let's check on this diagram. Trust, go to untrust, outbound. Let's say you want to perform a filtering from trust to untrust, you apply it to the outbound. When you want to filter untrust going into the trust, inbound. That will be the direction that you perform. So it still remembers that just now we mentioned on the priorities. The security zone priorities. Okay, XXP. So for untrust, 5. DMZ, 50. A trust, 85. Okay, so from trust to untrust, from trust to DMZ, from DMZ going to trust, DMZ, untrust. So from trust to untrust, so we call this as a outbound. From trust to DMZ, inbound or outbound. So in this case, you have to compare. When the higher priority go to the lower priority, it's always outbound. Just like this. When DMZ go to trust, it's outbound or inbound. So you have to compare who have a higher priorities. All right. So DMZ, 50. Trust, 85. So this one is inbound. When DMZ 50, untrust 5, that will be outbound. So this is how we're going to differentiate that either the traffic is incoming to that zone or outgoing from that zone. So it depends on how you perform the filtering in this case. It's all based on the inbound direction or the outbound direction. Okay, this is some of the tricky things you might need to grab some idea first, because this can be easily asked from your exam. So you need to know that how to differentiate either it's inbound or outbound. So for inbound is what? Inbound, low go to high. For outbound, high to low of the priorities. Okay, this is the priorities. So they have another one is a local, is 100. So it's the highest. So it means that for local go to anywhere is always outbound. For untrust, go to anywhere is always inbound. Okay, so please take note on this. What's the direction of the inbound and the direction of the outbound? Need to take note on this. It's important. All right. Next. So that is just an overview of the firewall itself. Next to it, we're going to look into the firewall function. What's the function of firewall they can provide? So you see that on the function of the firewalls, they provide routing, switching, security, UTM, LAN-WAN, unifying management. So under the routing, firewall itself, they can support static routing policy-based routing, RIP version 2, OSPF version 2, BGP version 4. So everything is still within the IPv4 at the moment. Okay. For the switch, they can have fast Ethernet, gigabit Ethernet, a VLAN, trunking, and .1T. That's most of what we mentioned yesterday. Under the security itself, they can provide the ACL, access control list, netting, a network address translation, VPN, L2TP, GRE, IPsec, SSL, point-to-point, and also the instant messaging that can be perform the protection. And the next one is a UTM, a unified threat management. So how are you going to prevent the virus attack using antivirus, intrusion prevention, anti-spam, URL filtering. Okay, this is one of the extra function, add-on function for the firewalls. So for this, you have a license to control of the UTM. By default, all the function under the security you should have without any licensing control. So for the LAN itself, they can provide PPP over Ethernet. So this is the two WAN connection they're supporting. So under the unifying management, how we're going to monitor using the SNMP version 2 or version 3, remote monitoring, okay, a spam. So how we're going to remote the interface, monitor the interface, TR069, and the Telnet SSL HTTP, FTP, TFTP, and the syslog. So this is mainly how you can manage from the user point of view, how you're going to manage the firewalls. That's the function that can be supported. Okay, but for us, normally when you're going to configure, a firewall, the very common way we are using the GUI. It means that using the HTTP or HTTPS. That is a two common way for us to using the GUI, a great mode to configure firewalls. Otherwise, CLI. CLI, they can using the telnet and SSH and perform the command line changes. So this is how we're going to be able to communicate, talk to the firewalls. So that is a functionality of the firewalls. So you can see that on the firewall itself, you can consider it's all in one boxes. The firewall itself can act as a routers. The firewall itself can act as a switches, security device that is a default, UTM can act as a WAN routers, and they have multiple way of the management to manage the firewalls. That is a function of the firewall. And the next one, the first I will say as a access control. Okay, access control. This access control is all depend on what you perform the ACL. That is a main function. A main firewall function by default is already there, is to identify the header and offer implementation measurement. So what they're going to perform here is you're going to set a different kind of the security policy with the access control list. Every single traffic, when they're going into the firewalls, then they will check the policy. The policy, they can base on the MAC, IP, TCP to perform the monitoring, the access control. So who can access, who can't access is all based on the ACL, or we call it as a policy, security policy. Okay, to know that either you're able to access or not able to access. That's the first one, a main function. And for the basic firewall function as in service awareness. So how they know that what service that you are using? Something like this. They can based on identify based on features field, application layer gateway, and the behaviors pattern. So under the SA, service awareness, so this service awareness, they go up to the layer 7. So throughout the layer 7, I will able to know that what type of application that you are using, what type of behavior of the pattern of the user. Okay, so they're able to have different the wide variety of the protocol signatures around on the internet. So they're going to keep track of what are the application that the user has been performing. Okay, either they're using something like they're using a point-to-point protocol, or they're using BitTorrent, or they're using online gaming, as well as they will have a stock trading. So all these signatures is be all around the internet that we can be easily monitor that what are the service that the user are using and what the most thing there has been performing, which traffic utilize the most of the bandwidth. Okay, so everything is based on the features, application gateway, and the behavior pattern of the user. So the firewall itself, they're going to control, they can monitor. Okay, so they can be inspect. They're going to in-depth inspection for every single bucket to identify your application layer protocol. So if we go up to your layer 7 to understand what are the application that you currently are running. So in this case, you can be easily perform the filtering based on the category. So let's say that right now I do not want to allow a P2P. So it can be just deny the entire category. So that is how the service awareness, because the service awareness, they're going to the in-depth inspection through the application layers, layer 7. All right. That's why we go up to. sorry. So the next one is on the SSCG, SSCG interworking technology. Under the SSCG interworking technology, what it stands for SSCG? First, we need to know what is SSCG first. It's called Security Access Control Gateway. Okay, this one it be applied into a campus network or the huge enterprise. They might need to have this SSCG. Okay, so I have all the different agents here. I have all the different agent. The agent is just included as a client. So I have my branch office. I have an agent throughout the internet. This is my local network. Okay, that is all my server. I have my management server, control server, and I have a patch server, antivirus server, and domain management server. I have a post authentication domain. So in this type of environment, what you're going to have, we are going to divide into the 3 logical domains. What we have, we're going to have a access domain. We have a pre-authentication and post-authentication. So they're going to divide it to 3 different domains: access domain, pre-authentication domain, and the post-authentication domain. So for the access domain is to install under the agent. So every single agent, they will have an access domain where they can access to. What are the policy they push into the agent? So you define under the switches. So some sort of like a dot 1x, a dot 1x to define under the switch to authenticate the agent. So when the agent connecting to the switch port, they will prompt for the pre-authentication. This under pre-authentication, it be over here. Okay, pre-authentication is over here. Under pre-authentication domain, what they have antivirus server, a patch server, domain management server. What they're going to perform here is, okay, right now when the traffic coming in, you want to do authentication. I want to authenticate either whether you are the correct person. I need to make sure that you are inside my domain. When yes, you are inside my domain, second thing I have to check, do your PC, patches of your PC, is it up to date? Your antivirus, is it up to date? So everything needs to be checked before you can go to the post authentication domain. Okay, so it means that everything needs to be authenticated, authorized already. Then only you can go for the post authentication domain and can be easily accessed to the resources that I share to the LAN or to the internet. Okay, so they will have one called UCL, user control list, using a user to control the list. So just like the access control list, but this one is called as a user control list to controlling the user, to provide the different policy to the external user and the internal user. So everything you need to do it very properly. And the only thing, the drawback is when you want to use the SSCG, all the environment, there must be as a Huawei environment to providing this entire method of the entire solution. Okay, so the firewall, when they receive, they redirect the traffic going to the pre-authentication. Before they can access into my network, I ask you to do the checking of your antivirus, the patches, and are you in the domain before you can go into all my post-authentication domain. So in this method, you'll be very safe. Okay, you'll be very safe when you're having this setup. Yeah, this is on the SSCG interworking technology. And the next one is on the dual system hot backup. So when your network growing and growing, one single firewall might not enough. So because when the firewall go down, everything will go down. Okay, you're not able to access to the internet. They will not able to handling all the traffic on the netting. That's why they will have one dual system hot backup. So they have a USG of active, USG of standby. So they differentiate that who is active, who is standby. By normal situation, all the trusted traffic, you're going through the active way. Return as an active way. But for this topic, in more in depth, I will going to cover later part. Because on the chapter number 4, they were going to just mention about the dual system hot backup. So they include the VRRP, VGMP, and the HRP. All right, this later part we're going to cover in depth, more in depth. All right, so I'm going to cover this later part. As well as the one called is an IP link. This IP link, the result of IP link is automatic inspection, can be referred by other function, and the main application include application in the static routing and application in the dual system hot backup. So this IP link is just to keep track whether your connection, okay, active. This is, let's say this is active. That is a standby. So they're going to active and standby. So how are you going to detect, make sure that the link are always up? So I'm going to send an ICMP to make sure that the link is reachable. When I found that my ICMP is unreachable, okay, unreachable. So when it's unreachable, I will say that right now this link and this link is unreachable. I'm going to switch over from the active to the standby. So I'm going to shift the connection. Using the IP link method, they have two applications that can be supported using the static routing as well as the dual system hot backup. By using the dual system hot backup, in this case, they are using the VRP to detect either the link is go up or the link is go down. Okay, something like this. When the traffic go across through a green line, when I found that the connections go down, then they will shift automatically going to the backup connection. All right, this is on the IP link itself, how they perform the automatic inspection to detect either my destination host is reachable or unreachable. And the next one, for the firewall itself, the support on the quality of service. So this enables firewall to provide the functions such as the traffic classification, traffic policing, traffic shaping, and congestion management and the congestion avoidance. So it's a basic of a differentiated service. So for this QoS, under the firewall, we can do the classification and marking, congestion monitoring, management, and the bandwidth guarantee. Guarantee over here, you can say that I perform the policing or shaping. So when the traffic packet receive, I classify what traffic you are. So which one, or this is priority of 7, 5, 4, 2, 0. So based on the classification and marking, based on the color that you receive, I mark a different numbers to tell that how important are you are. So when throughout the congestion monitoring, so I'm going to monitor whether the link is congested or not congested. Is all through the monitoring. So when the link is start congested, okay, when the congested happen, I need to think of a way how to manage the congestion. Okay, when congested, who can go out first? So I based on the priorities to send out the traffic, and also I can be guarantee the important traffic bandwidth. At least that I can reserve the amount of the bandwidth for dedicated priorities. So they ensure the service quality, improve the customer satisfaction, and also maximize resource utilized and improve the service quality through the firewalls. Okay, that is on the QoS they can provide. So actually, this QoS function will be very similar to the router's function. Whatever router QoS is supported, they can support through on the firewalls. And the next one is a log auditing. So the log auditing over here is for the firewalls, they will want things is called a e-log software. The firewall provide the user with a clear record of the network access and analyze for the references. It means that whichever happening into your firewall, they will need to collect all the log passing through the firewalls and implement the high-speed log transfer in binary log format, go into your log server. Throughout the log server, then you're going to perform analyze through your log servers. So they will have log server, or we call this as a syslog. So syslog will be the one who monitoring the log. They're going to analyze the log information that you have, that you collected through the firewalls. Okay, you can based on that to perform the auditing. So what are the most traffic sent across to the network? So all the log has been recorded down under the log auditing. And the firewall itself, they also can protect all the attack. They have a pre-attack defense has been enabled. They can have a traffic attack, scanning sniffing attack, malformed packet attack, special packet attack. All right. They have all the different type of attack has been able to prevent by the firewall by default. Right. So it depends on what type of attack defense you're enabling through the firewalls. So most common will be on the scanning and the sniffing. Okay. Traffic attack, most of them is on the DDoS. Okay. The distribution, denial of service. Okay. Distributed denial of service. So it means that they keep on try to congest your network through your LAN. All right. So they have all the special type of the traffic attack, scanning, and also sniffing. So this one is always based on they're going to scanning your IP address, your MAC address to act as a man in the middle. So that is on the scanning. So the malformed packet attack, this one is also on the ping of date attack. For the special packet attack, that can be based on a special one. It can be a Trojan or can be a special packet attack. They use a special packet to send to you that act as a normal packet. So they would, let's say you have some special packet they're going to send across. When the hacker know that as a packet, they can act as that special packet and try to attack internally. But this is seldom used in the network for the special packet attack. Most of the attack you will see on is a traffic attack. Not only a DDoS, they can have a TCP ACK or the TCP sync attack. So it means that the hacker keep on sending you the sync. I want to form the peer review. But after you acknowledge back to me, I will not acknowledge back to you. So it means that I will try to make the TCP connection half open. Just like normally for the TCP, as I mentioned just now, they need to go for three-way. When the TCP sync attack happen, I will send one. When I reply, that's all. The attacker will not send me the acknowledgement. So this is a sync, sync, act. That's on the normal circumstances. When they have an attack, they send you the sync, sync, then they have no more return anymore. This one requires a half open of the TCP. So you're going to go through the halfway of your TCP section, then you just stuck there. And your TCP, you will just keep on stuck until you expired before you remove. Okay, then all this type of attack defense can be prevented by the firewalls. For the firewall itself, they can also provide the packet statistic. So the firewall must collect and analyze the packet statistic to learn the status of the network traffic and connection between the intranet and also the internet. So I make sure that what are the most traffic that we're getting from based on the system statistic. Oh, most of the time I have a TCP section and a HTTP section. Then you have a three section for HTTP. So this one is good for you to perform the analyze or come up with a report to tell that, oh, throughout the week or throughout the month, what are the traffic the user are using. And the firewall analyze the packet statistic in the following two ways. Use a dedicated analyze software to analyze the traffic log after the event and static and statistic, and analyze some packet statistic in the real time. So it depends on which method that you are using for the firewall to analyze the packet. But most of the time, they are using on the first one. Use the dedicated analysis software. So in our way, we are using our NMS, a network management server who perform the analysis of the traffic log from the firewalls. And next is on the firewall blacklist. So definitely when you have a blacklist, you should have the whitelist as well. Okay, not everything is just a black, you should have a whitelist together as well. But let me explain the blacklist first. So when they analyze the packet from the 192.168.1.1, when this address is inside my blacklist, I will not go very in depth. When I know that you are blacklisted, I will immediately just discard the packet. Same thing to the whitelist. Whitelist, whichever in the whitelist, you still need to go in through the filtering, but at least that at the first place, you know that this packet is black or white. When it's under the blacklist, sorry, you have been blocked. You have been blacklisted. Let's say it's whitelist, that you will be allowed. So a blacklist of the list of IP address, the device discard the packet sent from the blacklist IP addresses when they first detect on your IP addresses. Mask the user with the specific IP addresses, and the method for the blacklist and IP address can be a static blacklist configured manually. Okay, for the dynamic blacklist, the firewall blacklist an IP address due to the attack, defend, or the IDS. This one is on the UTM. Okay, Unified Threat Management. So I'm going to automatically detect to say that, oh, if let's say this IP address 192.168.1.1, they keep on sending a DDoS come from this source address. When I detect through my UTM, I'm going to say that, hey, next time when I see 1.1, block me. Just block this under the dynamic blacklist. All right, so it can be specifying either you want to manually define or based on some algorithm to detect either this attack or that as a normal. Because sometimes I'm not sure that have you aware of this before or not. Let's say this is my LAN. Okay, connecting to my firewall and going to the WAN. So throughout my LAN, I should have multiple connection. All right. And for my WAN, it's just going to the internet. So most of the attack is come from where? We can say that it's come from WAN to the LAN. But sometimes it can be happen, the PC in the LAN, they're attacking each other as well. Or they send attack into the WAN. All right. But some of the like port scanning, Is a port scanning is an attack? Yes, firewall consider a port scanning as an attack, because when you have port scanning, you are going to open up to tell everybody, oh, which port has been enabled on my firewall. But sometimes, let's say you just want to perform this as a to check out, oh, what type of the port I have enabled. You are not want to attack. You just want to know what type of port I enable under my firewalls. So when I perform this port scanning to my firewalls, okay, by right firewall, you know that this is an attack. I'm going to block you to the blacklist. But when you know that this is not an attack, you can add this PC into the whitelist. So it seems that when it's under the whitelist, I will not perform any filtering. Even you have performed the port scanning as a considered as an attack, but it still allow you to pass through when you add the user or the IP address under the whitelist. All right, this is how they're going to perform under firewall blacklist and also a whitelist. So for the next one, as a server load balancing. So for the firewall, they can perform the server load balancing so that they can allocate the user traffic that access to the same IP address to the different server. Let's say that you have a virtual machine, virtual server 1, virtual server 2. This defined as a group 1 and group 2. They have a server 1, 2, 3, 4. Okay, so from the internally or externally, when they come in, they can be easily load balancing among these 4. Okay, the load balancing mechanism distribute user traffic to the multiple server in the following way, based on the virtual service technology, server health check, and the traffic-based forwarding. So most of the time, they will based on the virtual service technology. So let's say you have a multiple virtual machine serving the same server. Then in this case, you can using this method to do the server load balancing, or based on the server health check. So they're going to check which server is healthy. Then I'm going to send the traffic, user traffic to that server, or based on the traffic base forwarding. So you can say that certain traffic go to number 1, certain traffic go to server number 2, number 3, or number 4. It depends on how you specify this. Yeah, this is on the server load balancing. This can be enabled through the firewall. Firewall can help you to decide that either need to be load balanced or not. But definitely this one you need to be manually configured. So this need to be manually configure. Okay, for the load balancing. So as well as the support on the application control, as in what I mentioned just now on the SA, service awareness, use the SA knowledge base to inspect data flow for the point-to-point VoIP and the V2 data. And more in depth, identify almost all application layer service and control the traffic of the specific type, including allow and the blocking the packet, limiting the connection numbers and the rate limit. So I can be easily throughout the SA on the application control configure like this. So when I said that, oh, when I know that it's a point-to-point upload, okay, you can use, I give you 56 KB. The download, maybe will be slightly better, 256 KB. So I can identify very in-depth, and I can be specifying the rate limiting to every single application, as well as limiting the connection numbers. Oh, I said that, oh, point-to-point. Concurrent point-to-point connection is only 2 sections. 2 sections. VoIP, 20. Web TV, 1. Video conferencing, 20. FTP, 2. Email, 100. Something like this. So you can be easily specifying that how you're going to control based on the application, how you're going to set what are the rate limiting, and how either you want to block the application or allow the application. So I can say that I totally block point-to-point. No point-to-point allowed through my firewalls. Okay, this it can be applied into the firewall under the application control. But before you have this application control, the SA must be enabled to aware that what type of application that is supported into your firewalls. They can be understand what application layer they are using. And the next one is on the firewall performance indicator. They can, on the firewall itself, they have a performance indicator under the throughput. The maximum throughput, the traffic load that firewall can process at the same time. So that means that all the traffic coming in, how fast and what's the throughput can I generate out the traffic come out. So this one is all depend the different models. Okay, different models, they have different throughput. Definitely the highest end, definitely you have a huge throughput because of the faster processor, they come out with the better throughput. So effective throughput, the actual transmission rate per second, excluding the data due to the TCP packet drop and the retransmission. So they will just calculate the throughput based on the actual transmission per second. Okay, to identify that what are the max. All right, so next one. So for the performance indicator latency on the firewall itself, they also can calculate, they can form the performance indicator to define the latency of the firewalls. The time intervals from the first bit of the data packet going into the firewall to the last bit going out to the firewalls is used to measure the speed of the data process of the firewalls. So it means that there is the first bit that going out and the last bit going out, then they will check what's the time difference. That is the latency. The latency in totals that I'm going to calculate it through the firewalls. And the next one is on the new connection per second. The number of the new complete TCP connection established on the firewall per second. So how many concurrent connection they can be have per second? This indicator used to measure the real-time data flow process capabilities of the firewall. So it means that just like they calculate that how many sections that you in total you can have throughout the firewalls. It can be 10,000 or 100,000. So this also is all depend on your model as well. Different models, they can support a more connection. The connection they based on to calculate is always as a complete TCP connection established. All right, consider a single section. That is a concurrent. So this is a new connection per second, and this is concurrent connection. Because the firewall process packet based on a connection, the number of concurrent connection refers to the maximum number of connection that can be accommodated at the same time of the firewalls. One connection is a TCP UDP access attempt. When one connection is after attempt, successfully attempt, you consider one section. So it means that when this one is considered one already, sync, add sync. This one is considered one connection. So that's why a lot of hackers, they're going to using this way, send the TCP sync just to want you to attempt your connection. So every time you attempt, you will occupy one single connection. So to occupy all your maximum already, then you cannot have any new connection being formed. That's how the attacker try to attack based on access attempt. When attempt, if one consider a single connection already. So this one in total out what the concurrent connection they can be up to. So the host and the server at the same time on the firewall, yep, the maximum numbers. So this one is also based on the models. Different models, they're going to have a maximum number of the connection that can be supported. All right, next one. Throughout the next one is on the basic firewall configuration. So on the basic firewall configuration, I will show you that the step-by-step how to perform on the basic configuration through our firewall. So at the first starting, you start on the firewall itself. Under the Ethernet port mode, you have to specify already. Either this Ethernet port need to be layer 3 or layer 2. Okay, layer 2, it means as a transparent firewall. Layer 3, router firewall. This is a router firewalls. That is a transparent firewalls. Yeah, transparent firewall, you just have to use a single network segment. So for routed firewalls, you need to have 2 network segments. Then you set IP addresses. After you set IP addresses already, add the interface into the zone. So it depends on how many zones that you're going to define. They have a defined default zone and user defined zone. After a zone defined already, configure your network. Okay, configure your object, configure the policy, and start to perform the packet forwarding. So this is a process of how we set up the entire firewall as a basic firewall. So far, okay? So let's say you have any questions, you can just take note, then later you can ask the question after on the Q&A section. So this is on the command line itself, how to configure through the interface mode CLI. First, we are going to say that this is a USG system view. Then you go to the interface and configure either it's a layer 2 or layer 3. Layer 3, set the IP address. Layer 2, port switch. Port switch, it means that you are going to turn the layer 3 port, go to the layer 2 port. Okay, port switch. So that is how you're going to specify that which mode you are using. After that, define the security zone. Under the security zone, use the command called firewall zone, followed by the name. Okay. To create a security zone and enter the security zone view, do not configure the keyword name. The security zone view is displayed directly. The security zone is exit, then you do not need to define. You can be just put like, let's say you go to do this, a firewall zone. You can just go into the trust. This one, it go into the zone. Let's say you configure a firewall zone user defined. Then you're going through another prompt. The security zone does not exit, then the zone will be displayed. The name will be displayed. Okay. Run the set priorities to set the priority of the security zone. Again, the priority that can be support up to is from 1 to 100. Okay. 5, 50, 85, 100 has been defined. These 4 numbers you can't use again. You have to use all other numbers. Okay, be aware of this. So adding an interface into the security zone, run the system view that going to the firewall zone, followed by the name, and add the interface. So you need to know that which interface is belong to which zone. All right, so same step, go to our system view, firewall zone, followed by the name of the firewall zone. It can be a trust, it can be untrust, it can be DMZ, it can be local, or it can be user defined. After you go into the zone, add the interface into the zone. Just add interface followed by G001, let's say, something like this. And after that, configure the security policy. This security policy is start from the rules. Source, destination, action. So let's say I would say that, hey, for the first one, rules. This one is going to access internet. Source, zone, trust. Destination, zone, and trust. Action, permit. So this is how you're going to define the security policy to say that right now I create a new rules. It's called access internet. From the source of the trust, go to destination to the untrust, I allow. Okay, I allow all the traffic from trust to untrust. Because of over here, I didn't specify that what I need to be allowed, what are not to be allowed. Okay, action will be any. And from here, you can define the static route. You can define a default route. Okay, for you to access going out to the internet, how is specified on the system view, IP route static, as well as the system view IP route static 0000000, and your next hop IP address. That is your default route. One is default route, one is a static route. So for you to access for the interconnection network from the source to destination. So let's say from here, from trust to untrust. How you go to the untrust? Normally, you should have one default route for you to access out from your network. Okay, this is how we are going to configure the route. Definitely, it's not only that. On the route itself, they also can support IP, OSPF, even those BGP, they support as well as ISIS. Okay, all the protocol they should support. Okay, it just depends on interworking how it works. Normally, for the interworking from trust, it means that from the firewall, ISP, LAN. But what normally, how are we going to normally go out to the ISP? So normally we just point a gateway to the firewalls, or firewall give a gateway to the LAN. And between this, they can just as a static route going to the ISP, or just a point to point. So it depends on method from your point of view going to the service providers. Okay, so there is a two option that how you can perform on the configure route using the firewalls. So from here, maybe I can show you some of the basic stuff on the firewall itself. So this is on my simulator. So let me go in first. So that is my firewall. This one later I'm going to show you. This one is on the hot standby. So that's why you can see in front the HRP. Oh, sorry, I should change another one. Okay. So from this firewall number 2, so you see that under a firewall zone. So this is the zone in total I will have. I will have a DMZ, local, name, trust, untrust. So as I mentioned just now, let's say you're going to define a name. You have to define yourself. Okay, I will just add a test. So it created a new zone. Okay, a new zone. And this zone, you have to set interface. So set priority first. Set priorities 1 to 100. Let's say I put as a 20 and add interface. Which interface I should add into this firewalls? I can say it's on the G00. So it's up to which interface they're going to be assigned. Okay, this has been added. Okay, this has been used by someone. The interface has been added to the trust security zone. That's what I mentioned. One interface, they cannot belong more than one single zone. Okay, one interface belong to only a single zone. Maybe this one is difficult for you to view. Maybe let me just show you one more time over here. So for the firewalls zone, let's say I go to the trust, I do not put the name. I just put firewall zone trust. Okay, I check, display this. So right now on the trust zone, I have two interfaces in the trust zone. So when I go back again to the firewall zone name test, when I add interface G000, he give me the error. Tell me that the interface has been added to the trust security zone. So it cannot have a one interface belong to two zone. So what you need to do, you need to remove the zone from the trust and add it back. Okay, that is how you perform on the zone itself. So this one, I just give you some basic ideas that how you're specifying on the firewall basic configuration. All right, that is on the route configure route. Let me proceed. Okay, that will be the summary that we are going through on the basic stuff throughout on the firewalls. Okay, for the next one, so I'm going to open up another one, chapter number 3. Okay, so chapter number 3 over here, we are covered as in firewall security policy. So just now we go through the basic that how the firewall function, what type of mode they're providing, layer 2, layer 3, as a packet filtering, proxy, or stateful. So nowadays, all the firewall by default you consider as a stateful firewall already. So they're going to have this security policy applied for us to perform the access control. Who can access, who cannot access is through the security policy. So for the objective over here, is we are first go for the packet filtering. How we're going to use a security policy to perform packet filtering? A forwarding principle, firewall security policy, and the policy configuration. So at the end, it will show you that how to define the security policy configuration. First of all, under packet filtering overview, how they perform the packet filtering, like this. For the packet to be forwarded, the firewall obtain the packet headers and compare the headers information against the defined rules to determine whether the forward or discard the packet. So this key packet filtering throughout the ACL, based on ACL. This is very basic. This is how I use ACL itself to perform the packet filtering. So this one is not considered as a stateful. This is just a normal ACL filtering. So when I say that this PC, they can go to the regional office, that allow. Okay, this is allowed. But when I detected your destination is not going to the regional office or the other way around, and this is not allowed. So they have a default rules. They will have a default rules by default from the untrust to trust. By default, denied. That by default is already denied. All the traffic from untrust to trust has been denied. Okay, but definitely, let's say you're under regional office, you want to allow certain user can come in, then you need to define through the ACL who you allow them to come in. Under the packet filtering mechanism, they are going to compare information of MAC packet header, IP packet headers, TCP UDP packet headers. That is what they are going to compare based on the packet filtering. They can based on the source MAC, source destination MAC address, source IP and destination IP, source port, as well as the destination port. And under the data, for the TCP UDP packet, there are 5 elements constitute to the contribute while the SCL is defined according to information. So what you can define up to 7 type of the method. Okay. So we have a, let me write it down on top over here. We have a source MAC, destination MAC, source IP, destination IP, source port, destination port, and the protocol numbers. So there are, in total, there are 5 sections over here that can be compared up to for them to perform the filtering through the ACL. Okay, there is a 7 factors that can be applied into your at once ACL. So you can specify based on destination source and also the protocol to perform the packet filtering. So when compared to the firewall security policy, the definition over here, security policy is basic firewall security mechanism in which packets are filtered against specific rules to determine whether they can be forwarded by the firewall and perform integrated detection over the traffic content. Okay, so there are 1 extra things for the firewall security policy. First, they control the interzone traffic forwarding. They perform content security check. They'll check the content itself instead of just compare the element that I mentioned. And for this security policy, you also can apply. You can integrate detection as well as you can apply a content checking when you allow the traffic to pass through. So the measure of application that we use on the security policy is control the across firewall network access and the device access from the intranet going to the internet. So which traffic it be legal or illegal. So they're going to, based on your security policy, to specify either you passing through or not able to passing through. Something like the principle like this. For the security policy principle, I will have policy 0, policy 1. I will say that under my security policy, I allow packet from A, deny packet from B, and default policy action, deny. Okay, so the filter flow that pass through the firewall based on the defined rules, the keyword determine the action to be applied to flow that match the rules. Let's say right now my incoming flow, this is my incoming data. When the incoming data, they have a BBAA, BBB, AAA. So let's say I will have a CC as well at the back. All right, going to hit to the firewalls. How the firewall to perform? Firewall, you say that, all right, right now I search for the policy rules. When A come in, I will check policy number 0. Oh, allow, you pass through A. Second, allow, allow, allow. When B come in, they check policy 0. It is not matched. They go for the second policy, denied. So I will not send out to my outbound data flow. Deny, deny. A, okay, allowed, allowed. B, deny, deny. Then how about C? When C come in, first one is not matched. It's not matched the policy 0. It's not matched the policy 1. Go all the way to the default policy. They will have an implicit deny here is also deny. When they never match any policy, on the last policy is still denied. So C and C, it be denied. So final result that it be what allowed to pass through the firewalls. All right, like this. When going through the firewalls, they determine whether they perform the step-by-step. So perform based on policy 0, policy 1, and so on, up to the default policy action. So the firewall process packet according to the policy, whether it is allowed or denied, that will be the result. Only A can be going out. B and C will be blocked. All right, and this one is not only can be just like based on source port, destination port, your IP address, upper layer protocol. They can be also based on the schedule. They can set based on time range. Within the time range, I will filter you. Let's say beyond the time range, I will allow you. So they will have different type of the policy can be applied. Yeah, that is on the principle of the security policy. Under the packet filtering classification, they're going to have a interzone, intrazone, interface packet filtering. So let us check one at a time. Interzone. When from trust to untrust, we have an outbound, inbound. So when you do a packet filtering through the interzone, and that is where we need to use the inbound and outbound. So you still remember that when trust is what's the priorities? 85, go to 5 is outbound. When 5 go to 85, inbound. All right, that is on the interzone. From the interzone, you have to specify either it is inbound or outbound. For the intrazone packet filtering, let's say you are within a trust zone. In this case, this one you have to specify based on the a trust zone, whichever coming in from the trust, going out from the trust, they're going to be filtered. So in this case, you have no inbound or outbound, because it's all within the same zone. They will not specify based on interface. So it means that when I know that your destination is under intra, you'll be hit into the policy, the packet filtering. Or you can based on the interface packet filtering. So you have an inbound and the outbound from this interface. Coming in from this interface or going out from this interface. This one is called as an interface packet filtering. This one is just on the point of the local to the user, to the network. So they're going to have the inbound go to the firewall, outbound from the firewall. So these are the three options of the classification when you perform the packet filtering. So this is just purely packet itself only. It's not going up to the security policy on the firewall security policy. Next, for the firewall forwarding principle, how the firewall forward the traffic, interzone, intrazone, or interface based. But over here, they just give you one example as in interzone. From trust going to the untrust. So first, if it failed to match the session table before the first packet process, what they perform first? Search the routing tables. Based on the zone and direction, search for the interzone packet filtering rules. Check policy 0, policy 1, and all other policy. The default action for interzone packet filtering, you'll be denied. So first, they'll go for your policy zone. After that, if a match of the session table, perform subsequent packet process. If it's not the first packet, search for the session tables. So you still remember what the session table is over here. When you're using the stateful firewalls, they're going to keep track what you are going out, who you are, to create the session going out. Maybe later on this page, you can be easily clear about how the session is being created. So when the traffic coming in, they'll query the session tables. Does the session exit? When you are the first packet to come into me, your session is not exit. When it's not exit, then they will check whether session can be created or not. Query the server map tables, search for the route, implement packet filtering, and net. After that, create the session. So you see that is on where is the filtering here. Before filtering, you need to make sure that you have a route. You have a route going through the destination, Then only I implement the packet filter, check whether you allowed to go or not. Then after you allowed to go, never address translation kick in. Before you're going out, I create the section and send the packet. When you have no session exit. When you have session already, then implement security check, refresh the session tables, and forward the packet. All right. When only the first packet, they need to go through this process. When it's not the first packet, they will go through this process. Yeah, that is on the how the section tables created. All right. So for the status detection mechanism, how they detect on this information. With the status detection mechanism, after the first packet of one connection is detected, a session is established for the connection. Subsequent packet of the connection do not require the detection. Only the first packet, as I mentioned. When the session is already there, I will not create anymore. I will just continue doing the forwarding. When without the status detection mechanism, the system can establish session entry for the subsequent packet as long as the packet passed the security check, even though the first packet of the connection is not detected. So it depends on either you have a status detection or without the status detection. But definitely with this, it'll be more secure. At least that I know the status, because let's say without the status detection, I will keep on configure the sections. Yeah, so they're going to form this section like this: sync and sync act. Okay, to form the section as a one single section from the source to the destination, something like this. When the host 192.168.1.1 go to the server 1111 destination port, there is a source IP, source port, destination IP, destination port. So when I create a section, when it's going out, I will keep record. So what is your source IP? What is the source port? Where you want to go? Where is your destination port? The protocol that you're using, the user, and the application. Okay, I keep this information keep down into my tables. So packets that match the section are forwarded when the traffic return. So when return, this is a source IP. This is a source port. That is a destination IP, destination port. Then they will compare. The source IP, correct. Port, correct. Destination IP, correct. Destination port, correct. It's a TCP ABC telnet. All right, this section is okay. Then you can pass through the traffic back to the destination. So when going out, they create the section. When return, they check based on your section has been built. Yeah, this is how they're going to compare to each other under a same section. So the next one is on the how we're going to check the section tables by using a display firewall section tables. Right now in total, you have two sections. A first section is running on the telnet. A second section is running on the HTTP. So one is from 3.1, the other one is from 3.8. This is a source port, destination port. Source port, destination port. They're going to a different destination from different source. When you check on the verbose, let's say I want to check, this is the first section in detail. HTTP, VPN, public to public ID. Zone, trust to the local. Time to leave, 20 seconds. Sorry, it's a 20 minutes. Left for 90 minutes, 56 seconds. Output interface in loopback 0 next hop 127001. When this is from where to where. So for this section, actually it's from where to where? It's from the trust to local, to myself, to the firewall itself. Okay, but they still will keep the session tables. It's been built. Then the next one is on the section in the forwarding process. So bigger and bigger already. So that is showing you that the entire procedures when the firewall receive a packet, what are the performance that we perform. So let us go through one by one. On the left-hand side, on the top of the left-hand side, first, when receive a packet, they will check, do you have any MAC address filtering on the layer 2 filtering? Do you resolve the frame headers to keep the frame headers, the MAC address headers? Interface. So this packet is going to the layer 2 or a layer 3. Okay, when it's a layer 2, then we check the next hop interface going to the VLAN. When it's a layer 3, remove the frame header, go for the packet headers, check the IP binding, incoming interface bandwidth threshold, single packet attack defend. So that is what the route map they perform when the first receive the packet. Before the session table being queried, they're going to have any MAC address filtering, check your frame headers. On the interface, either go to layer 2 or layer 3, transparent or routed. Okay, when it's routed, resolve the packet headers, check your IP address. Do you have any IP and MAC binding apply under the interface? Incoming interface bandwidth threshold, do you have QoS enabled on that interface? Limit the rate of the limiting. Then followed by single packet attack defend. I will check based on my enable attack defend. Do this packet is attack or non-attack? Let's say everything is good, then only they will go to the check. Do you have a section of this packet? When it's a no, then they will go for the state inspection, blacklist, server mapping, server mapping, server map, server mapping, online user list, application associated tables, routing table, authentication policy, first packet processing, security policy matching, source net policy, limit of combination numbers, establish a section, then only go out to the packet forwarding. So let's say you have no sections defined. So they're going through all the steps across. So you found that all these steps they're going to go through, it'll be pretty long. But this one is before your security policy. Okay, before your security policy, they're going to check every single thing before they can go out to the packet forwarding. When let's say the session is exit, they will refresh the session, update online user list, perform a flow-based attack defend, a state inspection, session refresh, yes or no. Let's say yes, server load balancing, routing table policy, security policy matching, backlist, user redirection, and go to the bandwidth policy. Let's say their session is not refreshed, they just go direct to the server load balancing and go to the packet forwarding. So they're going to either establish or just refresh the sections. So it depends which way that you're going. When they receive the first packet, that is the method they perform. Just now what I mentioned that the security policy, this one is based on the content. This content involved of the AV, IPS, URL, filtering. So for your normal security policy is from here. Okay, this one is based on the rules that you define from zone to zone. Yeah, that is on the security policy. All right, so after the packet able to be forward, then they will go to the bandwidth policy. But before they can come through here, it's all depend on your policy here. Is either permitting or denying. When it's a deny, I will just stop. I will not send out the traffic at all. Only when it's permit, I will go and check the net Do we have any netting? Do we have limiting of the connection numbers? They said no, then I'll go for establish the section and send, do you have bandwidth policy? Check the contain, source netting, do you have any VPN defined, outbound interface, and forwarded the packet. So this is the entire process for every single packet they're passing through the firewall. They need to going through all the steps before they can be forwarded out the packet. So you see that they have a lot of steps, but by default, not all of them are enabled. So it depends on the method of the firewall you need to be act as. So it's not every single rules you need to be enabled, but definitely, which one is the must? The must. So for the first process over here is a must. They must have, but this one is optional. This one is optional. This one is optional. Yeah, this tree is optional. Do you have any binding? Do you have any limiting on the interface on the inbound? And do you enable the single packet attack defense? This is optional. So section, this one is compulsory. So this one is compulsory. This one is optional. This one, for these two, when you are using, these two happen only when using the multi-channel protocol. As I mentioned, like in FTP, then they will going through the server map and the server mapping. All right, let's say you are not using FTP, this tool is optional as well. Online user list, this is optional. Associate application associate tables, that is optional. Let's say using the multi-channel, this is compulsory. Routing table is compulsory. Authentication policy, that is optional. First packet process, security policy matching, net policy, optionals. Okay, that some of the information is compulsory. I will read out the optionals. So that must be going through, and under different way, they're using different method. So this one, optional, optional. Net is compulsory, optional, optionals. Okay, this one either you want to apply or not apply. So update online user list. This one, let's say you didn't define, then this is optionals. Perform flow-based attack defense, optionals. State inspection, session refresh, this server optionals, optionals. This is only happen when you enable the service load balancing. Okay, this optionals. This optionals. So they have a lot of optional process that you can be ignored, or you can just without that. So it depends on how fast that you want to handling the packet through the firewalls. Because you try not, I know that firewall is to protect your network. If let's say every single packet come into the firewall, they go to the in-depth inspection. In this case, you're going to have a slow processing. So you have a slow traffic back to the source or destination. Because every single packet is going to the depth inspection, then this is a problem already. So that's why they're going to split the role. Who are doing the netting? Who are doing the security policy? So normally what we did for this security policy, we're going to use another devices. Another device just to handling the contain filtering. Try not work together with the firewall. Although firewall can support on this function, but we recommend that you can have a dedicated device just to managing the contain filtering. Okay, this is the entire sections in the forwarding process they need to go in through. Some is mandatory, some is on the optionals. And the next one is on the multi-channel protocol technology. So as I mentioned just now, FTP is one. For single channel, www is only using port 80 only. They do not have any control and do not have any session export data. But for multi-channel protocol like FTP, in the passive FTP mode, you have a port 21, and the other one is a random port. Okay, they might not using 20, but they can be used any others of the port numbers. As well as when you talk about the zip trunk for the VoIP, the voice over IP, they're also using the multi-channel. They're using a control and a different data, as well as the H.323. This is also one of the voice protocol that required on the multi-channels. So how the firewall can be easily manage the multi-channels. So as I mentioned just now, when the firewall in the meters, so from the host to the destination server. So what they need to be matched, I consider you are under a same section. They will have a source IP, source port, destination IP, destination port. Then I'm going to create a section with all these 4 information: source IP, source port, destination IP, destination port, and the protocols. Okay, this need to be matched. So when the traffic go return back to the firewalls, back to the host, when the source IP is correct, but the source port is different already. When the source port is different, then they cannot match back the section. In this case, they will not allow the traffic to return back. And this caused the problem of the multi-channel protocol going across to the firewalls. And in this case, what we need. How can I use a pure packet filtering method to define port used by the multi-channel protocol at the port levels? Okay, a pure packet filtering method cannot define data flow for the protocol that use randomly negotiated port, because for this port it be negotiated out. Okay, it's not fixed port. So in this case, I very difficult to know that what port you coming back to me. So in this case, we are going to use the one called ASPF. For the normal pure packet filtering, they're not able to define the data flow for the protocol that used on the random port. So we are going to use the ASPF based on the application specific packet filtering, ASPF. It's an advanced filtering technology which checks the protocol information at the application layers and monitor status of the application layer protocol of the connection. For all connection, information on the connection status is maintained by the ASPF and used to dynamically determine the forward or discard packet. So what they're going to do here is, when the session, they're going to be created from here. The firewall is going to monitor packet during the communication. They take note that, oh, right now you are using the FTP. I send this traffic out. When return, they dynamically create and delete a filtering rules. When I match that you are come from the same application, I'm going to delete the old entry and create a new entry for the data forwarding and allow the traffic passing through. So over here, there is one example from here. So on the ASPF, apply the packet filter at the application layers. So from the host, go to the FTP server 20001. So they form this. Under the session tables, the source IP, source port, destination IP, destination port. I'm going to form using a port 21, go to FTP server. So then when the server said that, hey, I use the port 4952 to establish a data channel with you, when this information received by the firewalls, a firewall perform the server map tables. They're going to build these server map tables. Inside address is 20001, port 4952 is the TCP, FTP as a data traffic. Okay, act as a data traffic. So in this case, I will send to the host to tell that, hey, I'm using the 4952. So after this, after you reach to the destination, then this data channel has been built and said that is the source IP, source port, and destination IP, destination port. So they're going to refer back to the server mapping to create a dynamic information to build the to form the multi-channels protocol. So to allow this to pass through. Okay, so the firewall is very important to say that right now I need to allow FTP to running as a ASPF. I will compare based on your application. When I know you're using FTP, return traffic, you'll never use back 21. You will using a dynamic port. So in this case, after I return, I'm going to build a server map table to cap this as a FTP application. So at least they go to the application layer to tell that which application that you are running. That is on the ASPF. Under the server mapping entry, what they can keep track. So they can keep track based on the multi-channel protocol, as in like the FTP. So for the STUN, the STUN protocol such as the MSN, TFTP is all through the this is more to the UDP. Okay, a UDP. This is more to the TCP when you have multi-channel protocol. Netting or the net server or the SLB. So for all these four methods, they will going to perform to create the server mapping dynamically. So they will keep track. When going out and coming back, you might use a different port numbers. Then they're going to define the server map entry. The example that I showed just now is on the multiple channel protocol. Okay, so they should have others method like nowadays. I think nobody is using like MSN, like a QQ. They're all under a STUN protocol. There is more onto the real-time protocol. They need to have a server mapping as well because the port that you form the connection and the data, it should be different. Okay, that is on the server map entries. For the port identification, support the multi-channel protocol. So port identification is used to map a non-standard protocol. So let's say just now FTP is using 21, but now your FTP are using 31. It's not the standard. You change the port, it's just to prevent attack. But when you change on this port, you might affect your multi-channel protocol. So let's say you are going to change your FTP port, you need to perform the port identification at the beginning, something like this. Configure the ACL to allow this address 20001 and a port mapping of the protocol name FTP port 31 ACL 2000 followed by this 20001. So you need to have a port identification to say that right now you're modifying the port already. Otherwise, when you just change the port to 31 without inform the firewall will not able to perform the multi-channel protocol. Okay, aware of this. You have to, when you change your destination port numbers, you also need to add the port identification to tell the firewall. Right now, FTP 21 is changed to 31. So you have to inform the firewall when you receive a port 31, you are still need to perform the ASPF. All right. That is on the port identification through the multi-channel protocols. Okay. Okay, let me clear this. Okay, so form the control channels using the 31. And from the data channels. So which application protocol is used by the port 31? What should I do if I don't know? So in this case, what you need just need to do the port mapping. Okay. After you perform the port mapping, then they will identify that your FTP has been modified to the port 31 already. Because this one is very important. When you modify the destination port numbers of the application, remember perform the port identification. Then the next one is on the fragment cache. The device cache the fragmented packet that reached the device before the first fragment to the hash list of fragmented packet. What it means over here is, normally when you are fragmented packet, under the tag, they will say that, oh, this is a fragmented, this is a this is a fragmented n, 1 to n. Okay, it depends how many fragmented packet that has been defined. So on the normal network device transmit a packet, is the MTU configured on the packet is fragmented and then transmitted. They're going to be cut into the small piece. Every single size will be 1005. They're going to cut into small piece and forwarded out. But during the actual transmission, the first fragmented packet may not be the first one who arrived to the firewalls. So something like this. So this is my firewalls. The traffic going in out. So I have number 1, number 2, number 3. So this fragment number 1, fragment number 2, fragment number 3. They are belong to the same packet, but just fragmented to 3 because it's too huge. When I go into the firewall, might not the first fragmented packet go into the firewall, might be number 2 first. Okay, number 2 go into the firewall first, then followed by number 1, followed by number 3. So in this case, what will happen? When the firewall check that, oh, you are not the first fragmented packet, I will just drop. Okay, at the normal network device, they will drop. But let's say in a firewall, you enable a fragment cache. So I'm going to keep this. When you are not the first one, I keep into my cache. I will not drop. I keep into my cache and wait until your first one coming in. Then I perform the checking. Then I will say that, oh, this one is belong to this. I refer back to this fragmentation. Okay, that is what we call as a fragment cache. I'm going to keep as a record. I will not drop immediate when it's not the first fragmented packet go into the firewalls. The next one is on the long link. Why the long link? Section aging mechanism and problem brought by the section aging mechanism. So every single section is being built by the firewall. They will not keep for long. It max will be 10 minutes, 20 minutes. But the protocol that you are sent, if no data of the session is received before the session aging, the connection for this session may be terminated. But let's say I want to form a connection between the database and my client, but I perform this traffic forwarding 1 hour once. So it means that every time that I want to talk with my database, I'm going to create a session. In this case, you're going to be just give me a problem. Every time every single hour I send, I need to create a session. So that's why they will have one long link to say that, oh, this section that I built, I will not keep for 10 minutes. I will keep for 1 hour and 30 minutes. I keep longer. Instead of keep for 10 minutes, I keep for longer. Keep for 1 hour, or I can keep this section up to 24 hours. So it depends on how many hours they're going to be keep. So that on the long link that can be defined. So the default, let's say, is enable the long link. The default on the long link, they will keep it be 168 hours. They will keep this information, keep this section for 168 hours before they will remove from your firewall. So you have to be aware of this long link. Not every single session need to be enabled long link. Only a specific application or specific database, they might need to enable long link. Otherwise, your section might not enough. Let's say everybody using a long link. All right, that is on the firewall forwarding principle. And the last one is on the security policy and application. So under the matching principle of the security policy, as what I showed just now, when the trusted go to untrusted, they're going through the security policy and check one by one. When it match, it forward based on either permit or deny. When nothing match, default is denied. After that, if it's not the first packet, search for the session tables. They're going to check whether the session tables is applied or not. All right, this is on the principle of security policy. They need to go into every time going through the security policy and check either you'll be allowed or been denied. The procedure of the security policy, so that is a condition. Okay, the condition for the security policy compare just now the packet filtering. You will see the difference. Under packet filtering, we have only 7 information can be matched. We can match based on source IP, destination IP, source MAC, destination MAC, source port, destination port, and the protocol. These are the 7 information can be matched on the packet filtering. But under security policy, on the condition itself, under classification, that is what we can be classified. We can based on the zone of the security zone, source destination, source address, region, destination address or region, based on user itself, services, application layers, and based on schedule. So they can have a rich condition compare the packet filtering. This is what we can match based on packet filtering. But based on the security policy, they will have a rich amount of information. Okay, then next, action. The action is permit or deny. When it's denied, discard. When it's denied, it will just discard. When it's permit, then you can go for the profile. This profile is under a contain filtering. Under content filtering, you can go for the antivirus, intrusion prevention, URL filtering, file blocking, data filtering, application control, and mail filtering. So that it will be more advanced. So first, they're based on a condition, permit, deny, and this is the action. So this is what they apply through the profile content filtering. So this is on the procedure of the security policy. But when you set as a deny action, it will just discard. You will not go through the profile. So as in this example that we have here, we have 2 security policy. Security policy number 1, I don't care from where to where. When the user is a marketing, application for the instant messaging, gaming, deny. Okay, this is what I apply for the policy number 1. Policy number 2, I will say from any to any, user is marketing, HTTP, permit. When it's permit, they need to go through the antivirus and prevention, the intrusion prevention, the IPS, to prevent the Trojan and so on. All right, that is how you can be specifying based on the security policy. So security policy, you can consider this up to layer 7. For packet filtering, it's up to layer 4 maximum. Okay, because it can be based on the user. based on application to perform the action, permit or deny. All right. So marketing, it be allowed going through the HTTP. It be denied for the instant messaging and the gaming. This is what they're not allowed to going out. All right, that is on the security policy. To configure a security policy, that is a procedure. Start, then create the security zone, configure interface, configure user and authentication, object, profile, policy, and save and commit. So whichever under a gray color is optional. This is mandatory, this is mandatory, this mandatory, and this mandatory. Okay, so for the object, it's just all the group. The profile is on the contain filtering. That is optional. Okay, even without this, you also can be allowed or denied based on the policy that you have, that you define here. All right, so step by step from here, this is how we define a security policy. Based on security policy, I have a rules name, define a name. Do you have any zone? Have to specify from where to where. Can be any to any. You can from trust to untrust. And configure the source address, destination address. Can be based on address set, based on a group, range, and also geography location, based on what you define on the object, as well as the destination address. Okay, that is what I can define, as well as for how you're going to use the wildcard. The wildcard mask format is similar to the subnet mask format, but they have a different meanings. 0, match. 1 is not match. The wildcard mask is used with the IP address to specify an address range. 0000255, 003255, 0255, 255, 255. All right, so let's check here. What is the function of the wildcard mask of 0255, 0255? Do you have any ideas? So let's say that your address is 10.10.10.024. But your wildcard mask of this network will be 0.255.0.255. What it match in this case? It means that they need to be matched the first octet and the third octet. Need to be 1010, first and third. But second and the last can be any numbers. Okay, so it means that when you have this apply of the classification, I match 10, 1, 10, 1. I match 10, 20, 10, 20. I match 10, 30, 10, 1. I match 10, 255.1.1. Do I match on this? No. So this match, this match, this match, and the last one you will not match, because I need to make sure that the first octet and the third octet need to be 10. Okay, that is how the function of the wildcard. All right, this normally you be used under your ACL. Under access control list, they're going to use a wildcard to specifying. So configuring the security policy, follow just now, just continue from just now. Let's say you want to specify based on the user. Okay, you can specify the username or any user. Reference of the TCP UDP port numbers. This is under the port, layer 5 or layer 4. What port that need to be monitored. Configure the service. This service can be HTTP, can be ICMP, or can be IP service. So it depends on what type of service that you are referring to. Refer a security profile in the security policy rules. You want to have app control, AV, data filtering block, IPS, mule filtering, URL filtering. So that need to be defined in this case. And this is a set. This set considered as a group. The object group that you can be specifying. So this address is referred into your, so this is the address. The address set means that the group of the address. Then for the service set, it can be defined under the services over here. All right, so it can be two methods of defining this. You can define more than a group or just a services address as well. It can be combined everything within a single set. It acts as a object. So after that, apply. Do you want to have a time range schedule? Do you want to have a schedule on this policy? And the final one is the action. And this is the most important. So you need to set that either it's allowed or denied. So under this example here, I will say that from 2013-06, June 15, 1915, access the server during non-working hour is denied. When you under working hours, yes, it's permitted. So that is how we specify based on the time range. You can schedule your security policy within the time that be allowed or not allowed. So this is how you're going to set the time range. They can be set based on the time range followed by the name. Create an absolute time range, start time, start date. And the period range, start time to the end time, weekday or 1 to 7. This one is just set a fixed time range. This one is on the range. So from when to when, weekday, 1 to 7, or weekend. So you have to specify on the time range throughout the period of range. So you can have option of a daily, off day, working day. So the off day is represent Saturday, Sunday. Working day is Monday to Friday. So all these are the options under the operator and the syntax we can define. So you also can specifically define that on Monday, Tuesday, Wednesday, and so on. So which date need to be allowed. So the next one is on the example for the configuration and inter-zone forwarding policy. This is one example that show you to you how you work. In the enterprise employee on the 192.168.50.24 network segment, accept the PC as a 192.168.5.2, 5.3, and 5.6 can access internet. All right, so this 3 IP is allowed to the internet within this range 5.0. So it's under a trust zone. This 3 PC, .2, .3, .6, they're allowed going through the internet. So the policy I'm going to be built over here is, first, I will say that security policy, rules, name, policy, deny. Source address set IP deny, action deny. But at the first place, you have to specify the address set, which address is being denied, and create another policy to allow to access to the internet. So after the address has been denied, the rest will be allowed. So it's always based on sequence. Configuration sequence, this is the first sequence, and this is the second sequence. So first I deny first, then I will permit. You cannot say that this you permit first before you deny, because this one permit the entire range. All right, so that is how you perform on the security policy, as just a small example here. All right, so I do not have enough time for me to show you entire lab over here, but all this lab that you can be viewed through the e-learning. So I just give you some ideas of how to perform on this security policy. So that's all for these chapters on how we are performing the firewall on the packet filtering principle as well as the security policy principle. So we still have another 30 minutes. Let me just cover another last one, as in the chapter number 4, sorry. as called as a firewall dual system hot backup. For this firewall dual system hot backup, it means that when you're going to have dual firewall at the same time. So this over here, or for this objective, you're going to be mentioned about the principle of the dual hot backup principle. So under the principle of the hot backup, what we have, why is the dual system hot backup is developed? So when you have only a single firewall, the figure shows the traditional network mode. Firewall A is deployed between the intra and internet. If the firewall is A is 40, everything will be gone. All the data transfer will be interrupted. And this is what you do not want it. So therefore, for the communication reliability cannot be ensured when you have only a single firewall. So what to do? We are going to perform the dual system hot backup. This one is based on the routers. Under a routers environment, let's say it's not using a firewall. When you use a routers, we are using the VRRP. We can have one master, multiple backup. So first, you need to know what is a VRRP. VRRP stands for Virtual Routers Redundancy Protocols. That is a standard protocol for us to redundant when you have multiple devices going to the internet. So you can say that all the traffic must going through the master device. So I will define a virtual IP addresses. Within .2, .3, .4, I will say that, hey, .1 is my virtual IP. Everybody point to .1. I don't care what happened into my routers. When this go down, I still point to .1. When this go down, I still point to .1. So it will not affect on the user point of view. User do not need to keep on modifying their gateway to the destination. Okay, that is on the router dual system hot backup by using the VRRP. But under firewall, the VRRP for the firewall is a multi-zone backup. It's slightly different. This one is based on the zone. Under the trust, one zone, DMZ, one zone, and untrust. So in this situation, I'm going to have first VRRP, second VRRP, third VRRP. It means that every single zone, I need to connect to the two firewall and to perform the VRRP group for the redundancy. All right, so that needs to be redundancy, this needs to be redundancy, and this needs to be redundancy as well. So USGA, USGB, this is an active. This is a backup. So all the traffic, you go across to the active one. Under a normal situation, normal scenarios, all the traffic will be going to be flow from the active to the inactive, the untrust. DMZ go to the untrust. Same as when they return the traffic, they go using the same active firewalls. But what happened? What happened when they detect a failure of the connection? When the link connection go down on this interface, the traffic from PC on the trust going to the untrust, earlier on before the link failures is going to this way. But when the link failures happen, a traffic need to go into the backup. But after the backup received, the backup will be dropped. We will drop the traffic. Why? Because of the session tables. When you go out from this master firewalls, I keep the session tables. Am I right? When I keep the session table, I'm waiting for you to come back. When you return to another firewall that the session table is not being built under the backup, so very simple. it will just drop the traffic. So in this case, you have an issue already. When you are using the multi-zone backup of the dual firewall backup, you have to make sure that when this link go down, all the traffic on top need to going to below, need to be flow to the below. What it means over here is, under the traditional VRP cannot ensure the active standby firewall status consistency. Let me go back to the one slide earlier. So this is one group, this is one group, this is one group. This is the active, this is the active, this is a backup, this is a backup, active, backup. So when one of the group detect these link failures, this one is changed to active. But this one, it will not trigger the group number 1, group number 2. Okay, they will not trigger. They're not able to trigger the changes of my group 3. So you see that the link exchange is not consistent. That is what the disadvantage of the traditional VRP. They cannot ensure the active standby firewall status consistent. That's why in this situation, we have to define the VGMP group. We call it as a VRP group management protocol. I will say that under the VGMP group, number 1, I will have VRP group 1, group 2, and group 3. So I will have multiple groups within this VGMP group. So when my VGMP group go down, automatically this will go down, this will go down. This will become active, this will become active, and this will become active. They will shift all together to make it consistency. Okay, that is called the VGMP. We must have when you want to make it consistent. This is needed under a firewall, dual firewall redundancy, hot backup. We must have these VGMP protocols. All right, but by using the VGMP, your section tables are still not backed up into the standby. Your standby is still without the section tables. So it means that you still have the same issue when you are doing this VGMP, although the VRP successfully consistency of the failover, but not the section tables. So you're still having the same issue. So that is a principle. Let me just talk about the principle first. The VGMP status, they have master and the slave, and they have a hello. So they have a group of priority 65001 and 65000. That is a master and that is a slave. When master go down, slave take over. That will be the active, active, active. When the master, the slave take over. So that is how they perform. What they do, they just send the hello to alert everybody inside the same group. And this VGMP group is to make sure that the status consistency, whoever within the same group, they will shift all at a time. The VGMP group control the unified status switchover of all the VRP group and also preemption. When the original active device recover, its priority will be restored, then it preempt the device to the active device again. Okay, so that is what they can perform through the VGMP. So this VGMP is just for the VRRP for the status consistency. But for the session tables, we need to use another protocol. We call it as a Huawei redundancy protocol, HRP. Synchronize the key configuration and connection status of an active firewall to a standby firewall. So it means that I need to have one connection in between the two firewalls and say that whichever master configured, I will sync to the backup. I will do a synchronization to the backup. And this protocol is proprietary by Huawei only. So for other vendors, they should have their own method to provide this synchronization between the active and the backup firewalls. Okay, they're using the HRP to detect each other to synchronize the key configuration, not only the session tables. Whichever configuration changes on the master, you affect to the backup immediate. So let's say you create a new zone. The new zone will be replicate into the backup firewalls. All right, that is on the HRP basic principle. And for the quick session backup for the first packet, after the first packet, they're going to always back up to the standby. And for the backup for the refresh packet, so they will keep on synchronized between active to the standby. After modifying, I will just send to the standby. Standby, keep a record. So even those that when the traffic come back from the standby device, the standby, you know how to forward back to the destination. All right, that is on the HRP, Huawei Redundancy Protocol. So it means that throughout the dual firewalls hot standby, they must have a VRP involved, VGMP, as well as the HRP. These are the 3 steps need to be done to provide the dual firewall hot standby. All right, this is on the security section that we're going through on the dual system configuration on the next. So this configuration, it'll be pretty simple. So first, we need to specify the VRP group on the active firewalls and the backup firewalls. Okay, first we define the VRP on the interface, VRP on the interface. So it means that I have 2 VRP in this case. You need to configure VRP group of the upstream and downstream service interface so that the VGMP group can monitor the layer 3 service interface through the VRP group. So you need to configure VGMP between the USG-A and USG-B. For the VRP configuration, this will be learned under the HCNA, that how you define just to VRP, VRID, followed by router ID and the virtual IP address. Yeah, maximum you can up to 255 VRP group can be created. For the HRP, simple. HRP interface, HRP enable, HRP standby config enables, auto synchronize, mirror session enables. So all this need to be enabled. So you have to tell that HRP interface, which interface you're going to use as a HRP interface. So that's why they need to have a dedicated interface is for HRP. So you need to tell this interface to the destination interface, this interface to the destination interface with the IP address 10.10.01, 10.10.02, like this. Okay, interface number and the remote IP addresses. And enable the HRP, allow to configure the standby device. HRP standby config enables. So it means that when you configure on the master, you configure the standby as well. Auto backup configuration, auto sync. Okay, auto sync the config or auto sync the connection status. By default, they allow both. And mirror the section tables. So all this need to be enabled on both sides for you to perform on the HRP between the 2 firewalls. And this is configuration. Interface IP address, that is defined with VRP, and this is defined the backup VRP. After you configure this VRP already, next step is configure the enable HRP, enable which interface you are using to form the HRP. HRP enable, mirror, and enable the interface. So this very straightforward configuration. As long as you know how to define the VRP, HRP is not an issue. just make sure that between the two firewall, you need to have a dedicated connection between the firewalls. And that is what the VRP status. The VRP to tell that we is active as a master, active stated, virtual IP, virtual MAC, and so on. Yeah, that will be covered on the VRP itself. And the HRP just display the HRP status. When the HRP enable, in front, you should see that a HRP, active or a standby. All right, and these are the interface that you are using. You are using two VRP, VRID 1, VRID 2. So you have two VRP. So for this one, I will just show you a quick one into my firewalls. Sorry. So under my firewall over here, I will have this one. You said that it's a HRP master. I have another device. As a HRP standby. So I have active standby. So from here, I can be display HRP state. Sorry, state. So this is state. And also you can check the configuration. Sorry. Sorry, right now I'm under the master. I should do it on the under the standby. I should do it on the master. So you will find that for the master itself, what information I should assign, they should display the HRP state. HRP state. They will telling you that the role is active, your peer is a standby. So this priority is running, your peer priority is running. So for the stat active, you'll be higher than the backup. Okay, for this, it will run about 3 hours, 30 minutes already. They are not doing any changes. So you will find that whichever that I perform, when I said that I'm going to modify the information, I go to the firewall zone name. I'm going to create a user defined. Then I will set that set priorities 60. So you see that they have a plus B behind here. There is to add to the backup. They add the configuration into the backup routers. Okay, that is how you're going to do the synchronization of the configuration between the master and the backup. So throughout here, display firewall. Hold on, let me go into the firewall display security. It's called firewall zone. It's not in this, it's just a sections. Oh, this is just a section tables. So let me just double check with this command on the firewall zone. Never mind, I just display my current information. So this is all the things that I define. This is on the zone. So you see that on the standby, just now I add on the active master. I will have a set priority of 60 plus 8 on the user defined. So you see that they exact the same things over here with the set priority 60. So it will automatically, whatever you do it on the master, they will automatically sync to the backup. Okay, that will be easily to be synchronized between a master and backup using the Huawei redundancy protocol, the HRP. All right, this one is just roughly to show you the ideas about how the RPF been defined to configure it. All right, that's all for this on the dual system hot backup principle and also the configuration. So far, that is the topic they're going to cover for this section for the 3 hours that has been go through. And next step is the turn that you ask question. Do you have any question? Let's say you have any question, you just raise your hand, then I will unmute you, then you can ask your question. Is any question so far? So as in, let's say whoever attended yesterday, they have might ask a question about the ICT exam and the HCNA exam. There is equivalent. They are the same exam. So you just have to take once only. After you take the ICT exam, you do not need to go for the certification exam. They are equivalent. Okay. So any question so far? Any question, you just raise your hand. They have a button, raise your hand. No question. Yes, Cliff. Let me mute. Let me ask the host to unmute you first. Hold on. Okay. Yes.
Yeah. Hello, Nick.
Yes, Cliff.
So you said the competition exam is the same as
The certification exam.
Oh yeah, it's the same as the certification exam. That means when somebody does the competition, they get the same certificate as one who will do the CNA exam.
Yes, correct.
But then the competition covers almost all the certifications. It covers security, it covers routing and switching, cloud storage, big data. So what certificate do they get for after competition?
Actually, for the ICT exam, they also have a different exam as well. Under the ICT exam, they have INS, just purely INS, just purely security. So it depends on which exam you take, you will get the certification. They are not all combined together as single exam.
Oh, all right.
Let's say you go to the ICT exam, you will find that they have a list of exam you can be applied on your region. Then that will be the exam available only.
Thank you.
Okay, thank you, Chris. Do you have any other question from the rest? And because for today, by default, I will mute everybody. So in this case, they will have no any other noise except my noise. So as anything, you can just raise your hand. Yeah, Chris again. Yes.
Sorry, I forgot to ask one question. Among the trainings, the last training is on big data.
Big data.
Yes.
When is it? For
that's on 30th, 29th. Yeah, from is on 25th, 26th, 29th, 30th, and 31st.
Okay.
and then below it, there's the HCNA Big Data Online Learning Material, which the link doesn't seem to lead to any of that material. I don't know if that is also available or will be available later.
Maybe I have a look because what I covered for my site, I covered
Yes.
the INS, the HCNA
Yes.
INS, security, and WLAN. For big data, maybe
Yes.
I can have a look for you because they are not same track is what I cover right now.
Okay.
Give me a second.
All right. Just from the link, you see the link we had for the same link for the trainings.
Okay.
Like below routing and switching is online learning video, and then below security there's online
means that
learning video.
they will not redirect you to somewhere else, is it?
Yes. There's no notes where they redirect.
On the big data. Hold on.
Yes.
Okay. So normally that when I will go for the e-learning, I will go to this site. Maybe let me show you here. So you should on the Huawei, okay, Huawei.com.
Yes.
So under the training and certification.
Yes.
So you can start the carrier certification. HCNA Big Data, this one.
Yes.
When you select the training materials, they have no e-learning at the moment. I think it's not ready for the e-learning yet. So you might only able to get the training materials at the moment.
Okay. All right. Thank you.
Not the e-learning yet. Yes.
All right. Thank you.
You're welcome. But I think that in the later part they have another track on this as well. Maybe I can show you from here. Community forum. So that is on the track of the cloud. Yes. This is on storage. No, this is on the okay. This is what you mentioned, right? Big data.
Oh yes, exactly.
But when you click on this link, that they redirect you to, yeah, there's no e-learning at the moment. It's only on the training materials. So maybe you have to wait. I think because this one is on the almost end of October. I think they will come out very soon, maybe. So you can pre-study before you go for this training.
Okay.
Because this one will be pretty compressed as well. Because it's only how many days? 1, 2, 8. Oh, there are quite a lot of dates you can join actually. But they cover different information.
Okay.
Okay, but every single time you join is only 3 hours, so it's pretty limited. So that's why they have an e-learning for you to go through yourself with all others topics.
Okay. All right.
All right. Thank you.
Okay. Thank you so much.
Thank you. So any other questions so far? So for tomorrow we are going to cover the WLAN, Wi-Fi, okay, HCNA Wi-Fi. You also take 3 hours. I will cover 4 topics. There might have some of the hands-on I'm going to go through with you guys as well on the command line itself. Okay. So if let's say they have no any question, then I will call end of this section. All right. So for this security section, you also have all the e-learning online. You can refer to that as well. Because this one is pretty compressed for 3 hours. You can't learn everything from this section. So you have to still going through on the topic, all the topic through the e-learning. All right. Thank you, everyone. Thank you for joining to this training. So I will see you tomorrow. Thank you. And bye-bye.